Hi, my name is Cristina Miranda and I am going to talk about fluids. Fluids are a phase of matter and include liquids, gases, and plasma. Also, fluids exert pressure in all directions. We understand pressure as the force applied perpendicularly to the surface of an object per unit of area over which that force is distributed. Its algebraic representation is pressure equals force over area, and in the international systems of units, force is expressed in newtons, area in square meters, and pressure in newtons or square meters, called Pascal. Pascal's principle, or hydrostatics principles, states that change in pressure in any point of an enclosed fluid at rest is transmitted to all the points of the fluid and act in all the directions. For example, we can see this on the drain networks or in the gas distribution networks in home, but we are going to focus on the water distribution networks in home. When there is an increase in pressure at any point in a confined fluid, there is an equal increase in pressure to every other point of the container.
I am Ivan and I'm going to explain the problem of the stage 1. We need to find the force with this formula, so we need to know first the pressure, and by Pascal law we know that pressure from the sink is equal to the pressure of the pipeline. So the problem already gives us the pressure too, that is the pressure of the pipeline in the area of the sink. So we can do like a force, we can isolate this formula because we have the pressure in the area. But first we need to convert the area from centimeters squares to meters. And it is in meters squared, and then only we need to multiply the pressure, that is 2 kilopascals times this, and that will be equal to 0.06 newtons.
Hi, I am Eduardo. Heat has a variety of terms that I can explain, like environmental cooling in buildings, thermal interchange devices, atmospheric phenomena, and heat sources in home, but I'm going to talk about the last one. Heat is a form of energy that can be transferred from one object to another. It can be transferred by radiation, convection, and conduction. One of the most common forms to transfer heat in our houses is by conduction, like when you turn on the stove to heat water. Another is the radiation, when the ambient is very cold and you turn on the radiator. And convection is like when you put a glass with ice in a surface and it begins to heat because of the air that is transferring the heat that is in the ambient.
In the problem, we need to heat up 0.5 kilograms of water by conduction, and we need these two formulas. The first one is with a specific heat, and the second one with latent heat. And here's the procedure. Here, the second heat is the one that you need to only transform it to solid into liquid, and this other heat is to convert the from 0 to 10 degrees, and because both are heats, they are measured in joules, and this is the final result.
Electricity and magnetism. Electricity is the flow of electrons through a conductor. We have two types of charges, that is the positive charge and the negative charge. The law of charges establish that like charges repel each other and unlike charges will attract each other. We always have electricity in energy generation, electric energy sources, magnetic field generation in overhead cables, and in household electric circuits. There are three types of circuits that are series, parallel, and mixed. The most common household electric circuit is the parallel circuit, because if you have a switch for different bulbs, the flow of electrons will continue passing even if a bulb stops working.
I'm going to explain a parallel circuit. In this circuit, the first resistor is of 3, the second one of 2, and the third one of 4. First of all, in parallel circuits, the voltage is the same. In this case, it is 18 volts. To get the total current, we only need to add the currents of each resistor, and this is the formula to get the total resistance. And once we substitute in the formula, we obtain this. And then to find the total current, we have 18 here because of the same. In the parallel circuits, we have the same voltage, and we only need to change the measure of each resistor. Then we get these values, and we only need to add them.
My name is Jesus, and I'm going to explain about sound, waves, and optics. There are 5 main points I want to expose. The first is about the sound sources, that can be divided into 2, natural and man-made. The natural are the sounds that came from nature, and the man-made are the sounds that came from objects that the human create. For example, cars, trains, helicopters, airplanes, among others. The second point is about the sound transmission. There is a transmission of sound through certain materials. The third point is about the measurement of the sound intensity, that normally is measured in the decibel scale. The fourth point is about the optic devices, for example, projectors, cameras, telescopes, among others. The fifth point is in the one that I want to explain a little bit more, that is about the sound speed. The sound speed is the speed of waves of sound in the air. The sound speed depends on the substance that it is traveling. For example, it is very slowly in gases. Its velocity is approximately of 330 meters per second. Then it is a little bit faster in liquids. Its velocity is approximately of 1,500 meters per second. Then in solids it is more faster than in the other two. Its velocity is approximately of 5,000 meters per second. To finalize, the sound speed increases 0.6 meters per second for each Celsius degree that the temperature
I am going to
increases.
explain how to calculate the speed of sound depending on the temperature. This is the principal formula, and from this formula we can get that when the temperature is 0, the velocity is 330 meters per second. In the formula always the velocity is this one, so if we do the problem with the temperature is 16.66, we only need to put this value here and multiply 0.6 times this, and the result will be 340, and that velocity is the one that is recognized as the speed of the sound in normal conditions.